Hi, this presentation is about the differences between accuracy and precision and how to calculate percent error. In chemistry and in sciences, when you're measuring things, you need to decide how close you are to the correct answer, and you will talk about things like accuracy and precision. Accuracy refers to the closeness of the measurements to the correct or accepted value of the quantity measured, whereas precision refers to the closeness of a set of measurements to the same quantity made in the same way. So, what does that mean? In accuracy, you are hitting the bullseye. These are accurate readings, all four of these here in this first graphic. Precision in this second graphic would be that every time you've thrown the dart, you've landed in the same area. All four of them are precise. You've managed to repeat the toss and get to the same spot. Now, in this second graphic, you're not very accurate because you did not hit the bullseye, and typically that's where you're aiming. But you were precise, you were able to repeat your result. In this last graphic over here, you have four different throws who are not even in the same range, and so I would not call these precise or accurate because none of them got to the center. So the end goal would be that you actually throw all of your darts in the center of the bullseye, but we're not always that good. So the difference between accuracy and precision: accuracy is what you put to the real result where you wanted to be, the bullseye. Precision is landing all of your trials in a similar range of answer. So that leads us to, how do you decide how much error you have? So percentage error is often what we calculate in chemistry, and it's calculated by subtracting the accepted value from the experimental value and dividing the difference by the accepted value, and then taking the whole thing times 100%. So they often use things like experimental and accepted. There can be other word choices here. You will see this portion in an absolute value. Percent error is always reported as a positive answer, so it doesn't matter if your experimental is bigger or smaller than your accepted value. You should ignore the negative sign. So here's an example of calculating percent error. The sample problem says a student measures the mass and the volume of a substance and calculates the density as 1.40 grams per milliliter. The correct or accepted value of the density is 1.30 grams per milliliter. What is the percentage error of the student's measurement? So we need to compare the accepted and the experimental value, and then we will subtract the two, divide by the accepted, and multiply by 100. So when you set that up, it looks like this: 1.4 minus 1.3 divided by the 1.3, that whole thing would be an absolute value, times 100, and that would mean that in that mathematical computation, you got 7.7% error. You will need to use this percent error calculation again. Most often we use it whenever we're doing labs. Part of your conclusion section is discussing the percent error that you have occurred as a result of your lab results. So you will need to come back to this and do this in the future.